Alright, welcome to the lunchtime video. We're going to be moving on to a new topic today. In the last video we finished route targets. Now I don't know what they mean by route targets. They might just mean be comfortable configuring a route target, which I think I am. You can do it in a number of ways. You can do it directly under the routing instance using the word route target, or you can do it using a BGP community string. In addition to that, there's also something called route target filtering, where you actually use the route targets to use to send your traffic. And the advantage of that is, since you're using route targets and not individual routes, everything that is assigned to a particular routing instance can be treated with one identifier, thereby dramatically increasing your scaling ability even more. So when you have millions upon millions of routes inside of your routing instance, you can just use a route target to route your routes instead of the individual routes themselves. I think I might be a little bit wrong about that. I might be going in and getting some things wrong. But the bad news is, as far as the last video was concerned, I couldn't get it to work, this concept of route target filtering, because the route targets weren't being accepted by the route reflector, because the next hop was a IPv4 address, but the destination prefix was a route target. So very clearly a IPv4 address is not going to be a proper next hop for a route target. I would think that a route target would be, or anyway, I'm just not sure what was required. I really had no idea. And I will just say that between videos I did tinker around with this a bit last night, and I found ways to kind of manipulate the next hop using like a policy and all that, but I just had to give it up. I could not find a way to get this working. So with any luck, this route targets category just means be comfortable using a route target. Make sure not to forget one when you're configuring the L3 VPN, and does not mean something more complicated like set up route target filtering and use route targets to exchange traffic instead of the routes themselves. If that comes up, there is built-in help on the CLI help apropos, but that might get me if that comes up. So hopefully that doesn't come up. Let's move on to egress node protection. Okay, and then let's do the same old of using the help apropos. Okay, so maybe this is it, because yeah, so let's start with this. Yeah, so enabling egress features. So maybe one of these features is node protection. So let's filter that out. Nope, nothing for... Okay, so we got nothing specifically for node protection, but I think this is going to be very relevant, so I'll read this regardless. Enabling egress features on a hub PE router. This example is provided in conjunction with configuring hub and spoke VPN topologies, one interface. This example also uses the topology illustrated in example of hub and spoke VPN topology with one interface. If egress features are needed on the hub PE that require an IP forwarding lookup on the hub VRF routing table, the configuration detailed in configuring hub and spoke VPN topologies one interface will not work. Applying the VRF label table table label statement on the hub routing instance forces traffic from remote spoke PE to be forwarded to the hub PE and forces an IP lookup to be performed. Because specific spoke routes are in the hub VRF table, traffic will be forwarded to a spoke PE without going through the hub CE. The hub PE advertises the default route as follows, using VPN label 1028. Incoming traffic is forwarded using VPN label 1028. The MPLS.0 table shows that an IP lookup in the table hub.inet.0 is required. However, the hub VRF table hub.inet.0 contains specific spoke routes. Because of this, traffic is forwarded directly to the spoke PEs without going through the central CE. To prevent this, you must configure a secondary routing instance for downstream traffic in the hub PE1. When the no VRF advertise statement is used at the edit routing instances hub hierarchy level, no routing table groups or VRF export policies are required. The no VRF advertise statement configures the hub PE not to advertise VPN routes from the primary routing instance hub. These routes are instead advertised from the secondary routing instance hub _downstream. See the routing instances configuration guidelines in the Junos routing protocols configuration guide for more information about no VRF advertised statements. The auto export statement at the edit routing instances hub downstream routing options hierarchy level identifies routes exported from the hub instance to the hub downstream instance by looking at the route targets defined for each routing instance. See routing instances configuration guidelines in the Junos routing protocols configuration guide for more information about using the auto export statement. See configuring overlapping VPNs using automatic route export for more examples of export policy. With this configuration on hub PE, spoke to spoke CE traffic goes through the hub CE and permits egress features such as filtering to be enabled on the hub PE. In this configuration example, traffic forwarding is as follows between spoke CE2 and spoke CE3. Number one, spoke CE2 forwards traffic using the default route learned from spoke CE2 through BGP. Number two, spoke CE2 does a route lookup in the spoke VRF table and forwards the traffic to hub PE1 through the P router. PE2 pushes two labels using the default route learned through BGP. Number three, hub PE1 does a route lookup in the MPLS.0 table for the VPN label 1029. The VPN label 1029 is advertised because A, the VRF table label statement is applied at the edit routing instances hub downstream hierarchy level in the hub PE1 configuration. The no VRF advertise statement is applied at the edit routing instances hub hierarchy level, instructing the router to advertise the route from the secondary table. Therefore, IP lookups are performed in the hub_downstream.net.0 table and not in the hub.inet.0 table. Issue the show route advertising protocol command on the hub PE to a spoke PE to verify the VPN label 1029 advertisement. Show route advertising protocol. Number 4. Hub PE1 performs an IEP lookup on the hub_downstream.inet.0 table and forwards the traffic out interface TE000.0 to hub CE1. The primary routing table is hub.inet.0, indicating that this route was exported from table hub.inet.0 into this hub_downstream.inet.0 table as a result of the no VRF advertise statement at the edit routing instances hub hierarchy level and the auto export statement at the edit routing instances hub downstream routing options hierarchy level in the hub PE1 configuration. Hub CE1 forwards the traffic back to hub PE1 using the router learned through BGP. Number 5, hub PE1 performs a route lookup in the hub VRF table and forwards the traffic to spoke PE3 through the P router. PE1 pushes to labels. Number 7, spoke PE3 performs a route lookup in the MPLS.0 table for VPN label 100128. Number 8, the last one, spoke PE3 forwards traffic out interface TE000.0 to spoke CE3. So this kind of leads me to believe that I think I know what was going wrong. I think in addition to IBGP, I also needed MPLS enabled. That's how it was going to exchange this. But right now we're learning about egress node protection. So yeah, nothing too useful in the help apropos. So let's look again, see if there's anything that pops up. But I think I want to get to that Google search as soon as possible, so I have more time to actually work on the problem instead of just finding documentation relating to it. Huh. Okay, yeah, so unfortunately nothing too good. Maybe it's like abbreviated strangely like route target filtering was. This looks like it. Ah, here we go, perfect. Egress protection in layer 3 VPNs. Yep, this looks like it exactly. This topic introduces the concept and components in egress protection in Layer 3 VPN. It describes and provides examples on how to configure the protected, protector, and point of local repair (PLR) routers. Egress protection for BGP labeled Unicast. When network node or link failures occur, it takes some time to restore service using traditional routing table convergence. Local repair procedures can provide much faster restoration by establishing local protection as close to a failure as possible. Fast protection for egress nodes is available to services in which BGP labeled Unicast interconnects, IGP areas, levels, or autonomous systems, ASs. If a provider router detects that an egress router, AS, or area border router is down, it immediately forwards the traffic destined to that router to a protector router that forwards the traffic downstream to the destination. To provide egress protection for BGP labeled Unicast, the protector node must create a backup state for downstream destinations before the failure happens. The basic idea of the solution is that the protector node constructs a forwarding state associated with the protected node and relays the MPLS labels assigned by the protected node further downstream to the final destination. This feature supports the applications inter-AS option C and seamless MPLS. Inter-AS option C, BGP labeled Unicast provides end-to-end transport label switched paths, LSPs, by stitching the intra-AS LSPs together. AS boundary routers run eBGP to other AS boundary routers to exchange labels for /32 PE loopback routes. iBGP runs between the provider edge router and AS boundary routers within each AS. In Figure 1, the traffic goes from CE1 to CE2. ASBR1 is the protected AS boundary router. ASBR2 is the protector. And device P1 is the point of local repair, PLR. The primary path is chosen from PE1 to PE2 over ASBR1 and ASBR3. When ASBR1 fails, router P1 detects the ASBR1 failure and forwards the traffic to ASBR2, which provides backup service and forwards the traffic downstream. Seamless MPLS. BGP labeled Unicast provides end-to-end transport LSPs by stitching the intra-area level LSPs. Area border routers, ABRs, run BGP labeled Unicast to other ABRs to exchange labels for /32 PE loopback routes. In Figure 2, the traffic goes from device CE1 to device CE2. ABR1 is the protected ABR, ABR2 is the protector, and T1 is the PLR. The primary path is chosen from PE1 to PE2 over ABR1 and ABR3. When ABR1 fails, router T1 detects the ABR1 failure and forwards the traffic to ABR2, which provides backup service and forwards the traffic downstream. In each of these applications, the protected node advertises a primary BGP labeled Unicast route that needs protection. When fast protection is enabled, BGP advertises the label routes with a special address as the next hop. This special address is a context identifier that is configured through the CLI. The protected node also advertises the context identifier in IGP and a null label in LDP for the context identifier. The backup node advertises backup BGP labeled unicast routes for the protected routes. The protector node forwards traffic to the backup node using the labels advertised by the backup node. The protector node provides the backup service by cross-connecting the labels originated by the protected node and the labels originated by the backup node. The protector node forwards the traffic to the backup node in case of failure of the protected node. The protector node advertises the same context identifier into IGP with high metric. Also, it advertises a real label in LDP for the context identifier. The protector node listens for the BGP labeled unicast routes advertised by both the protected node and backup node and populates the context label table and backup forwarding information base. When traffic with the real context label distribution protocol label arrives, the lookup is done in the context of a protected node. The protector node often acts as a backup node. The point of local repair detects the protected node failure. Oh, there's like a huge eagle outside. And forwards the MPLS traffic to the protector node. The high IGP metric along with the LDP label advertised by the protector node ensure that the PLR uses the protector node as an LDP backup LSP. There are two supported protection types: co-located protector and centralized protector. In co-located type, the protector node is also the backup node. In the centralized type, the backup node is different from the protector node. Configuring egress protection for BGP labeled unicast. Fast protection for egress nodes is available to services in which BGP labeled unicast interconnects IGP areas, levels, or ASs, autonomous systems. If a provider router detects that an egress router, autonomous system, or area border router is down, it immediately forwards the traffic destined to that router to a protector router that forwards the traffic downstream to the destination. Before configuring egress protection for BGP labeled unicast, ensure that all routers in the AS or area are running Junos OS 1.4.1 or later release. 19 is going to be used on the test, 17 I'm using in my lab. To configure egress protection for BGP labeled unicast, add the following configuration to the protected router. So it's going to be MPLS egress protection with a context identifier, and then it's going to be calling the context identifier under family INET labeled unicast. Okay, and then in addition to that, add the following configuration to the protector router. So you've got a protected router, which you're going to configure MPLS and BGP. MPLS, you're going to set up egress protection with a context identifier. BGP, you're going to call in that configuration under family INET labeled unicast. Oops, actually, never mind. No, you're not going to call in the configuration. You're actually just going to configure it for both protocols. So yeah, you've got this context ID, but I think you'll have to use the same context ID. I'm not sure about that. Okay, and then on the next router, looks like pretty similar configuration. You just don't need the context ID under the BGP. Okay, and you also need to configure the point of local repair router. Okay. I'm curious if point of local repair shows up in the help at all. Nope. Yeah. NLRI configured with egress protection. Okay, so here we can configure egress protection for BGP labeled Unicast. This looks like a pretty good, yeah, this looks like a pretty good example. So let's include this in the notes and try to do this actually. Yeah, let's try to do this whole lab. So I've got a half an hour now, and then I'll be doing an after work video as well. The after work video will be a little bit later. Okay, so configuring egress protection for BGP labeled Unicast. Okay. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 routers. That's a bit more than I can do, I think. But I can probably get by with just 8 and then use Cisco's for these two. So I think what I'm going to do is destroy this whole thing. I would have loved to have been able to just grind my teeth and get it to work. And you know what? You know, I might be able to if I set up, yeah, before I tear it down actually, I'm going to be setting up MPLS on it. Now I'm really surprised to see this label switch command used without RSVP. I did not think that was possible. Let me try enabling RSVP on all 4 of these and then set up a label switch path full mesh between the PEs, and we'll see if that works. If that works, then hey, you know, that's good news. I just want to get my head straight on this because I've been taking an L on a number of these subjects, walking away being more confused than when I walk towards it, which is not always a bad thing. I mean, you're going to be more confused if you thought you understood something and it turns out you completely did not understand. So it's not a bad thing that I'm more confused going in than going out. It's just, you know, I want to have the answers because I'm going to be taking a test on this, and if I go into the test and don't do it right, I'm not going to pass the test. So let's do configure private. And I'm the kind of person that, like, if I don't know something, like, I'm often, like, more comfortable just admitting I don't know something, or, like, you know, then I would be going in and trying to form an opinion. Like I'd rather not have an opinion about something important than have an opinion that is wrong or dangerous or harmful. Okay, so let's see here. We've got oh, right, we're setting up so set protocols RSVP interface all, set protocols MPLS interface all, and then it's not going to be quite as easy as that. Yep, we still need to do set interface 0, and then it's going to be family MPLS. Yep, for 1 and 2 as well. There you go. So actually we won't need it for the interfaces that are facing that are not facing the core. So we actually won't need it for interfaces 1 and 2. So just for simplicity's sake, I'm going to actually remove it from those. I mean, there's kind of no harm in having it there, but I just want to have a better understanding of how it actually works instead of just randomly configuring things here and there, and if they happen to work, that's great. I mean, during the test, I'm not opposed to doing that, especially if I can get full points for it, but during practice, I better know the right answers. Oops. Okay, so we've got that's configured. The next step is going to be a full mesh between all the routers. Okay. Okay, so we'll put this command front and center again, because we're going to need to use that for the other two. Alright, time for PE3. Okay, so let's take a look at these pseudo wires. Okay, and they're all up. But unfortunately, doesn't make a bit of a difference when it comes to those route targets. I do have, in between videos, I did go ahead and create a route target filtering prefix list that include all my route targets, and then I did explicitly create another one called send targets, and in my BGP we do have a send targets. Let's do one final thing, and let's look at the yeah, so let's do a show route hidden. Okay, so yeah, we still got them with a unusable next hop. Show route receive protocol BGP. Hidden. Yeah, so we still got that next hop, which is unfortunately unusable. I guess I want to get rid of the next hop self policy I've got on here. Just anything that says self. Oops, looks like it's raining outside. Kind of distracted me there. I wasn't expecting that. It was looking pretty sunny and not very cloudy a few moments ago. So that was kind of surprising. Let's do a... Yeah. So let's look at these routes again and see if the next hop is the same. It looks like it is. God, that really sucks. Yeah, I'm having so much trouble letting this go. Like, it looks like I'm working on this now again, even though I know I need to move on. This is really not okay for me to be not using my time effectively with such little time to spare. So I think I'm just going to wait for this to come up and these to go back into hidden. So, summary. Fetch one. So it should, yeah, now it's in connect, it's in open sense, so confirm. Okay, we're established again. So we should have hidden routes come back, yeah, with the same invalid next hops. So I have no idea what the problem is. It wasn't fixed simply by having. I know there's a knob to toggle that will put routes in the inet.3 table. So I'm interested in trying to toggle that knob somehow. Yeah, I think it's right here. So I think this is what I would need to toggle. Yeah, so let's try toggling this knob on all of them. Protocols MPLS traffic. Okay, and I'm not sure, I don't think this is going to do anything, but I'm just curious, and being able to remember it is, I think, going to be important on the test, because I have one more thing I can try last-ditch effort to make a difference, and whoa! Okay, well that's weird. Yeah, as I said, it was sunny and nights outside, and then it started raining, and now it's like thunderstorming in a matter of less than a minute later. Okay, so let's see here. So yeah, we've still got the same. Oops. Yeah, we still got the same invalid next hops, unfortunately. Oops, I didn't add it to this one yet though, so let's do that. Go. Okay, so they're still hidden. Yeah. They're still showing up as hidden. Okay, so I've got to move on. I'm really shooting myself in the foot right now. I know how bad this is, so I'm gonna do. So we need 8 routers. So I'm gonna get rid of all these Ciscos. Okay, and I'm gonna get rid of all these links. Alright, and then I'll rename this to router 4. Okay, and then I'll rename all of them. This is going to be router 1. Oops, and it looks like I accidentally double selected, so now this is named router 1. So we'll just name that to 4. Oops, and I double selected again, so I named this to 4. So let's name this to X, and let's make sure I'm single selecting. Okay, and then we'll name this to X. Okay, single select. Name this to, we'll just name it router 1 right now. Okay, and then these are all, yeah, named all weird. Okay, so we'll rename these as well. We'll double select and rename both. So this is going to be R1. Okay, so let's double select and then rename. This is going to be R2 and then R2. Perfect. We don't need that. Okay, and then we'll call this one R3. Alright, and this one will be R4. Alright, so we've got all of these good to go. I'm going to place the others, and then while those are booting up, I'll go in and clear these off. Okay, so we started up all of them. So let's clean up the first 4 here. Okay, so those are all wiped clean. Now we'll need to, well, you know what? I don't need to just sit here and wait for these to come up. What I can do is get started on rudders 1, 2, 3, and 8. Okay, but this is going to be rudder 8, so might just be able to get through 1, 2, and 3. Oops, and it looks like, okay, rudder 7 is going to be a Cisco. So yeah, this should be renamed to rudder 9, placed here, and then rudder 7 will have being a Cisco. Oops, so it looks like I'm, there we go. Okay, rename to rudder 9, placed there. Rudder 4 is going to be here. Rudder 9. Rudder 6 and rudder 5. Perfect. Okay, and I might as well just even put the shapes in there. Oops, no. Let's see here. Yeah, there we go. Okay. Alright, so it looks like I got about 10 minutes. I don't have a hard 1 o'clock meeting deadline. So let's get started. And it looks like we've even got good descriptions here, make it a lot easier on me. So we're going to start with router 1, and we're going to have a link from port 0 to router 0. I guess I'm not sure which. Maybe it says in the topology. Nope, it doesn't. Okay, well, I'll leave off the cabling for now. Come back later and do it. Right now, I'll just focus on the actual configuration. Okay, so yeah, and it looks like they actually got everything right finally. They're not using unit numbers that are different from 0 without using VLAN tagging. Everything looks good to go. They've got family MPLS and they added there. This looks like pretty solid documentation. Hopefully this can help really make this make sense to me, because right now I'm kind of lost. But that's to be expected because this is the new topic. I did go over it in the previous, when I studied for the previous version of the test, but that was a long time ago. It's really raining. Autonomous system. Okay, so this now there are, it's not perfect because we can see we've got label switch paths, but the entire difference between LDP and RSVP is LDP is just super easy to configure. All you do is you set protocols to OSP. LDP, it takes care of the rest. RSVP, you enable because you want more control, and you're going to have to configure these statements when you enable RSVP, which can get pretty unwieldy if you have a lot of nodes. So in this configuration, they have misconfiguration because they say to configure something that depends on having RSVP configured, but instead they have LDP configured. So we'll just do it as it comes, and then we'll troubleshoot it, but that's going to be the obvious solution to that problem. Oh, you know what? That might be why my old topology didn't work, because I didn't have labeled Unicast enabled. Well, it's gone now. We gotta keep moving. Yeah, I've still got layer 2 VPNs to get through. I've still got multicast. I've still got class of service. There's really no time to waste at all. So yeah, and so now here's the problem. It's going to require protocols RSVP instead of protocols LWP, but we'll try it because if this just pops up on the exam, I want to be able to troubleshoot it easily and quickly. So if one of the problems is that it is configured this way, I want to be able to find that right away. Oh, and it looks like I accidentally missed some of this command, so let's go back to that. Perfect. Okay, so it looks like I'm at 11:59, so I would have loved to have gotten through this whole router, but I've still got routing instances configuration left, and I'm out of time, so that'll be in the after work video. Thanks for watching, and see you then.